Good evening. Good evening, faculties, and good evening to all. Welcome to the PantechELearning. Yeah, okay. So, good evening, everyone. So, once again, welcome to the PantechELearning. So, already you have completed the 3 days session of FDP. This faculty. Yeah. Yeah, good evening, everyone. Good evening, Vino Telongo, sir, and Narayana Murthy, good evening. Rajanmati Raj, good evening. Angam Saravanan, good evening. Ganapati Nagarajan, good evening. Good evening, everyone. Hello. சொல்லுண்ணா. அடிக்குதா? சரி, ஓகே, இந்த பார்க்குறேன். Yeah, so now it's good. Now my voice and presentation, everything is good. Are any problems or any issues? Am I audible? Hello. Hello. Yeah, thank you. Thank you, Narayana Murthy, sir. Thank you for your response. Okay, so now I continue. So last 3 days session, we was discuss about what is AI and what is computer vision and what is machine learning. So this kind of things already you was discussed, right? So last session you have to discuss the analog system, right? So this is speedometer analog system. This kind of topic you have to discuss, right? So today we have to go with that traffic sign recognition. So one of the AI concept. So we have to create one kind of model and train the model. In that particular model, how to find out the particular image. That means now it's a recent trend. So we focus on the particular concept, that is autonomous vehicle. That means driverless car, right? Elon Musk and most of the car industry is focused on driverless car, like automatic car, Tesla car, like. So the most important thing is the car was recognize everything, right? So based on the real world objects and the traffic signals and everything, we have to identify. The particular car was identified, right? சீக்கிரம் போட்டு போடா. Yeah. So in this particular concept, we have to train the model. In the particular model is having every traffic signals, right? So we have multiple signals. So red signal, green and yellow. So based on the crossings and zebra crossing and narrow bend and school zone and also working zone, construction zone. These multiple traffic signals are there. So in the every signal, the particular automatic car was written, understand, like recognition. So how it has happened, this kind of one format we have to see in this particular session. Okay. So that is the concept is traffic sign recognition using artificial intelligence. Okay. So yeah. So what is the agenda like in flow of this particular concept means first introduction of this particular topic and objective, what is our major motto of objective, and what data set we have to use. Finally, what is the workflow of this particular traffic sign recognition. So first one, introduction. So introduction about the particular concept, topic. So in this era, already I said, in this era of artificial intelligence, humans are becoming a more dependent technology. So just now I said the multinational companies like Google, Tesla, Uber, Ford, Audi, Toyota, most of the car companies is focusing on the automatic vehicle. So with driverless car. So in the driverless cars, most important thing, the self-driving car is working without human action. So that is most important here. So where the vehicle itself behave like a driver and does not need any human guidance to run the road. Researchers are running many algorithms to ensure the 100% road safety and accuracy. One such algorithm is traffic sign recognition that we talk about in this session. So this already I said in oral thing. So this paragraph also said same thing. So it's the introduction of traffic sign recognition. So what are the data set we have to use? So around 50,000 pictures we have to use for our training purpose. Our model training we need a 50,000 pictures. And only the model has to be perfectly trained. Okay, so the speed limit, crossing, traffic signal, zebra crossing, and narrow bend, hill station, railway crossing, so everything the car will have to understand. So the particular 50,000 pictures we have to classify into the 443 different classes. Okay, so for example, the red signal means the red signal is having some kind of 1,000 plus images are there. So zebra crossing having 1,000 plus pictures. Why we have to need this means that each and every picture is based on the different location or different position, different angles. That is easy to understanding. The particular car have to understand particular sign. What is that sign is exactly that. Because of the car drive, we cannot predict. So the car is only focus on this lane. So randomly is going to the ground or cross road or any construction work is there means they have to slowly run. So these different things is there, right? So the position also differ. So we need to each and every position is need to understanding the particular model. So then only we have using the around 50,000 pictures. So compressed into the 43 different classes. So this is our data set and workflow. What is the workflow of this one? So the data set exploration, second one CNN modeling and model training and validation, finally model testing. First thing we have, what are the data set we have to explore, so it is fit for our model training or not. Next one CNN modeling, so we have to create a neural network for our image, because of our data is image data, so definitely we have to use in the deep learning. And model training and validation, so based on our model training process and how it is work, we have to come to a prediction, so like based on the score wise. Finally we have to test our model, so how it is working, so properly predict the image or not. So based on the image wise, is that image which kind of signal? It is a red signal, zebra crossing or construction work or railway crossing. So what is that? Whatever it is. So this is the major 4 steps. So next one we have to individually see, that is data set exploration. Around 43 subfolders we need. So already said the ranging of that 0 to still 42 index are available in our training folder, and each subfolder represents the different classes. So we have an OS module that helps in the iteration of all the images with their respective classes and the labels. So one by one the classes have to be trained based on the model wise. So the first 0th index class is a construction signal. So first the particular folder have to fulfill, the class have to fulfill, then is move on to the next folder. That means the next class. Okay, so now I have to show one thing. So you can see I have to show the folders. Yeah, okay. So now the folder is there, the traffic sign integration. So it's a traffic sign dataset. I have an individual folder for this particular dataset. So inside the dataset, I have split it, individually. So train and test individually I have to split it. So first one is a trained one. So you can see I think it's on around 42, so but it's not in order, so we have to see it in an order format, ascending. Okay, wait a second. Okay, so now you can see starting to 0 to, okay, you have to, so still 0, starting with the 0 to still 42 classes. So I have to show in the slide, right? So in the slide we have a 43 class subfolders. So everything is having 0 to 42 index. Okay, you have to increase in the size. Yeah. So we have to see the first one. So first 0th index is having which kind of image? Okay, I think it's a speed limit, right? Yeah, it is a speed limit one. So 20 speed limit. So we have to see the another image. So same like that. So different angle and different position. So the image is there. And clarity of the image. So first one is speed limit. So second folder, so based on the individual folders is having some kind of classes, some kind of work. So now I have to see in this one. So the 21th index. Okay, it's a narrow band. Now I said. So each and every folder is having the different signs, signals. So in this images we have to using for our training purpose. So I have individually having the testing data sets also there, test images also there individually. Yeah, it is randomly the images are there. So around 10,000 plus images I having in testing purpose. So using the 2047 473 index. It is a down road. I mean the road is downstairs like that way. And try with that 470. Okay, what is that exactly? I think it's not overtaking like that way it is said. Okay, so this is the way we have to using the different classes based on the images wise. So next one, model building. That means we can creating a CNN model. So we build a model to classify the image into that respective categories. So first we have to create the architecture of the model. So that means we know. So you deep learning you have to learn in the last previous sessions. So we have an architecture of the deep learning. So input layer and hidden layer, finally output layer. So in this hidden layer, the data has to process. So that is which kind of data we have. So we have to extracting the data based on the neuron space. We are extracting the features. So next one is a convolutional 2D layer. That means layer wise. So first one layer, convolution 2D layer. Next one is a maximum pooling layer. Third one is a dropout layer, and again convolution 2D. Finally, it's going to the dense layer. The dense layer is a final layer. We can say it like that. It is a output layer. Okay, so this is the way the architecture we have to build to extracting the data. The CNN model already you know. Maybe deep learning you have to learn this. So this is the process of convolution operation. So first our image is splitting into this kind of neuron counts. So it's every place is mentioned with the neuron values 4, 9, 2, 5 like that. Individually, the every pixel is having like one of the values. So the image is splitting into these two kind of filters. the every filters is splitting into the 4 into 3 kind of kernel size. 4 cross 3 kernel size. That means 4 row, 4 column, individually 3 kind of filters wise. I mean 3 kind of frame wise it has to filter. I mean splitted. So that is compressed into the 3 cross 3. This 3 cross 3 kernel comes into the one particular, like 2 particular layers. That is 3 cross 3, that is 3 rows, 3 columns into the 2 kind of frames. Finally, it is going to the ReLU layer. The ReLU layer have to classify it is which kind of details inside the particular image. So based on the values wise. Finally, it comes to the output layer. That is, output is having, it is a particular signal. It is a zebra crossing, a narrow bend, or construction, so whatever it is. So this is the way the image has to be processed, and the image pixel value will be splitting into the layer by layer. I mean the particular convolutional layer. So next one is a kernel. So what is the meaning of the kernel? Means the one particular inches is represented to the kernel. That means here you can see in this particular place is called as a kernel. So this is the entire image. So the entire image is not taking into the whole values. That is splitted into the individual kernel. That is, we have to set like a what is that frame. So just now I had to set. So it is one of the kernel. Another is one of the kernel. That is 4 cross 4. So 3 kind of kernels. You have to splitting like this. Here also same like that. It's a kernel size. That is the image patch. The kernel is value is an exact value is 1, 2, 3. So randomly the values will be assigned. So 0 to 1 is the computer understanding format. So the exact value is here you can see there is randomly 492 is that. That is the weight values of the particular image, like pixel value. So which one is the highest value? That is the final output. So it's same like that. Every kernel is having calculating the some kind of sum of values. So this kernel is having one sum of value. This kernel is having one sum of value. So based on the every kernel is having the individual value. Finally, the every value is considered. That is one of the object. So a filter that is used to extract the features from the images. So the kernel is a matrix that moves over the input data and performs the dot product with the sub region of input and gets the output as the matrix of dot products. Dot product is nothing but our image, input image. So next was the paddings. So the paddings is helpful to avoid the loss values. So every kind of process during the training purpose, training process, the loss is definitely have. So any kind of product we have to make, definitely some kind of losses there, right? So here in the loss values to affecting to our prediction. So we need to avoid the particular loss values. So we have to using some kind of padding value. That means a dummy layer we have to create. So to increase the size of the output and save the information presented in the corners, we can using the padding layers, where padding helps by adding extra rows and columns on the outer dimension of the image. So the size of input data will remain similar to the output data. So just now I said the output layer is help to protect, protect the particular informations in our pixel value, like image values. So to avoid the losses, that's it, simply said. So next is the maximum pooling layer. So here we can see, before the slides we have to see, right? Here each and every kernel is having some kind of values. Finally, in this particular layer, it is output from the convolution layer. So in this one, it is output from the convolution layer. Same like that, multiple times the values has been processed. So every kernel came out from the maximum values only. That is our exact output. So here, so is one of the kernel, is one of the kernels, so one of the kernels. That is 4 cross 4, right? That is 4 kind of kernels is there. So every kernels we have to get into the maximum value. That is our output, exact object value. So in this place, one kind of image shade is there. So in this place, one kind of image shade is there. So everything will be combined. We have to get one kind of object. That object is which one? So finally, we have based on our classes names and classes labels, we have to find out it is that particular sign. Finally, we came out with one kind of output. So here the maximum value is a 9. So in this place maximum value is a 7. Here the maximum value is a 8. Here maximum value is a 6. So the maximum pooling is major work. You get it the maximum values to get it from the particular kernel. So next one is a flattening. So flattening is so every values is represented into the single dimension. Here the multiple dimensions, the multi rows and multi columns. Already we know the arrays, how it is work, how it is assigned. So row versus column, that is 2-dimensional or multi-dimension array. So everything we have to splitting into the single layer, like a single dimension. That is the flattened one. That is help to get it the output. So flattened layer we have to easily find out. So 4 is the maximum value. So we have to easily find out the particular output. Okay. So same like here also. Here the maximum value is a 3. So 3 is our exact output. So the model has to be easily came out the particular object name or object prediction. So next one is a fully connected layer. This is one of the architecture of CNN model. Yes, this is the input image. So as a user, we know about this. So it's like a zebra image. I already we know. So just now I said, right? So the kernel means it is represented to the one part of the particular image. That is the kernel. So here the input image passing into the first convolution plus value layer is one of the layer. So it's the input layers, output layer. In between that, some kind of hidden layers is there. The hidden layers is individually the label is mentioned like that. That is convolutional, pooling, and flatten, and fully connected like that. First, the kernel passing into the convolution layer. Again, it's move on to the multiple based on the image data wise. The layer has to be decided. So the layers has convolutional to maximum pooling. Finally, it comes to the flattened layer. The flattened layer has to represent each and every value based on the kernel wise. So individual kernel having the individual values. So here if the values are passed, the output layer has to decide so which one is the highest value, that is our exact output. So here the 0.2, 0.7, 0.1. So why? Because of these kind of labels. So each label is having the different creature, different species. So why? Because of the every animals look like similar. So because of horse, lion, cat, and dog. So every animal is having the 4 legs, and the structure is common. So some kind of difference is there. So we have to identify the particular difference. So more or less horse and zebra is look like same, but what is the difference in both means the line of the particular animal's body, that is zebra and the horse, they have to vary it. So the zebra is having the high value, that is our input. The model has to be predict like that. The original output, original object value is 0.7. Automatically it is decided to it is a zebra. This is the way the image has to be predicted. Okay. And so next one is the model training. So still we have to see how it is processed. Here we have to train our model. So we will using our model to fit method that works well after successful of our model building. With the help of the batch size 32, we get nearly 90% above on training data set and epochs 15. The batch size 32 means the each label they having to 32 individually. So that means each class, okay, one kind of each class. The speed limit is one of the class. The particular class is splitting into the 32 batch. Same like us, every class is having the 32 kind of batches is there. So that every batches and every classes have to be 15 times they have duration have to training. 15 time of epochs they have to training process. That means time duration we have to say. And model testing. So next model testing is we will use model dot fit. So it's our testing to our model because already we have to create the model, right? So same like that the model test method. Okay, is more or less same. Yeah. So what will after the model building, you have to batch 32 already we know. The 15 epochs is above training session. We have to using for our testing process. After the 15 epochs completed, we have to see the model testing how it is happened based on the score wise. Okay. So theoretical way how we can create everything. So now I have to go entering into the coding concept, how we can create and process everything. I have to explain you. Finally, I have to run the code and I will show so how it is happening, how it is predicted and everything. Okay, so here the code is there. Okay, so here already I have to using the models. So once I trying to create the training, first I have to show the training process. Okay, so you can see, so these are all the libraries if you have to, okay, oh sorry, I have to create, open the folder. Oh sorry. Okay, so now it's created, so I have to go with the traffic sign.py. That means this is our training code. I have to individually codes the training code on one of the file and testing code is one of the file. I have to individually is that. So okay, so now this is the libraries. So numpy is help to understanding the numerical values, and pyarrow is help to identify the images, and matplotlib is creating the plot of the particular image, and TensorFlow is help to Arduino. It is a deep image is there. We have to need a TensorFlow for our training process, and the image is a pixel value, and import OS means get it the image from our system, and SQL model selection for our training purpose and splitting data and testing data, and the categories we have to identify the individual classes, and sequential and layers is having. Individually we have to mention in the label of this hidden layers. So convolution 2D, maximum pooling 2D, dense layer, flattened layer, dropout layer, everything. First thing, we don't know about our data and the labels. Okay, so we don't know. So we have to create the empty list. Once we have to pass it our data, automatically the values are storing into this particular empty list. So labels, name and data and everything store it into the values are stored into the empty list in behind the process. Okay, so first thing we have to mentioning the path of our data, and the looping wise we have to identify. So the path of OS, that path dot join. So this is the curing, cursor path is a data path. So we have to train. So already, okay, where is the train data set here. So the train is there. So I have to copy the path and paste it here also once again. So it is not much needed, just in the only keyword is needed for ours. So I have to reduce the everything. Oops. Okay, I have to reduce that others. So just that enough for us. So once I save this, if I run this, automatically it is used. So once I fully explain this one, after that I have to run this code. So images is equal to os.leader, so list directory. So based on the data space, the image wise, the every image is stored into our one particular list, that label and data list. So the images has to open and resize the image and array values of image, and the append of the image into the data, and the labels one by one is added. In case the one particular image is not reader means the error loading image, the keyword we have to notify. And every values are storing into the data and the labels individually. So already we have a individual list. Okay. So both are individually stored. Next is splitting the data. So splitting and training and testing the data. So x test 1, x test 2, y test 1, y test 2, like that way. So already machine learning concept already we see this, right? So data labels we have to pass. Test size 0.2. That means 20% is a testing size, 80% is our training size. Random state is tabling our score value. So we have to finally see that shape 1, training shape 1, training shape 2, and testing shape 1, testing shape 2, like that. So category wise we have to represent. So already we know 43 classes is there. The range is 0 to 42. So next the model building. So sequential model we have to create the architecture. Then the layers has to be passed. So conversion 2D. So two kind of layers we need for our individual extraction. First the conversion 2D layer, the maximum 2D means extracting the maximum value of in this particular one. So again is going to the maximum 2D, convolutional, again is extracting the value. There is two more times they have to need this particular process. Then we have to come to a kind of identification. So which is with this kind of object. Finally the softmax has to be decided. So this is this particular object is a speed limit signal, it is a zebra crossing signal, it is a school zone signal. Based on which the softmax is softmax function has to be decided. Next one, compiler. The model has to be smoothly working. For our working flow we have to using the compiler, that is the Adam optimizer we have to use. And training our model is processed. Once the model has to be trained, we have to store the model file into the my_model.h file. This kind of way we have to store it our model. So finally we have to store it. Okay, I'm not representing to the pandas. Okay, wait a second. So it is using for accuracy score. Okay, first thing we have to training the model and save the model is then my model of h5 file. Here we have to check in the score values. So here I have to store it to import pandas sp. Okay, so pandas is help to find out the accuracy score of our model. So here the y test have to fix that. So read the CSV. Already we have a CSV file individually, and ID and path wise the images has to be resized. Finally we have to check the score value of our model. So our model is, okay, where is the model? Yeah, so model has to be saved into the traffic classifier. Once I run this, the model is one by one it is executed. So training start 1, 2, 3, still like that. So I think it takes some time because of the training purpose. We have to give it to the 15 count of epochs. So one by one it is executed. So it takes some time. So if I newly created this kind of model means we need a time. So once it's done, then only we have to go with that another process. But here not like that. Already I have to train and executed the process. Now I have to show you and give a demonstration about this particular one. So again I have to show you for your understanding. I have to run this one. So the training process and everything. So it takes some time. So once it is done, we have to see. So we will try to share this presentation and this source files. So you can try with yourself. You can get it some kind of ideas. So definitely it takes some time because of we have around 50,000 images. Okay, so it is running. So we can hold this. Okay, what is that? Okay, the file not found error. Okay, because our training file is not there. Okay, I have to try this. Yeah, here. So because of the path is having some errors. So we will try this one, and once again run this. What? Unicode escape error. Okay. now it's executed again. Okay, so it is running, so we have to go with the next one. Okay, so I already told this is already executed one. Okay, so because of I try with that a different different editor, so I mean a different platform, then only the error is happen. Okay, so once I sort out this error, I have to share the code, so you can try it yourself. So okay, now we have to go with that direct GUI, because of already I got to create the my model H5 and classifier model, everything I have to create. So already we have a trained model, so easily we have to see that output. Okay, so I have to go with that next one, so that is GUI of our what is the traffic sign model. So you can see, so what is the GUI means, we have to create the one particular user interface for our easy understanding of our prediction. So import tkinter is using tkinter is help to creating the front end UI creation. It's a framework to create the UI. So file dialog and everything and image tk. So we have to pass it our image and we can create some kind of buttons and pass it to our information and everything. Okay. So same like the numpy to handling the handling the values, and the keras is help to load the model. So we have to load it our mymodel.h5, that is our trained model. So here we have to mention in the classes. So first index having this 20 km speed limit, second index having the 30 km per hour speed limit, third index is 50 km. So individual classes having the individual labels. 10th one is a no passing, 11th one is a no passing vehicle over 3.5 ton, and 15 is a stop one, and general caution, double curve, and a bumpy road, slippery road. So around 43 classes is individually having individual labels. So here the initializing the GUI. So here we have to answer, mentioning the classes based on the label wise. In this place we have to initialize the GUI. So top dot tkinter of our model. So geometry is the frame rate of the length and width of our frame, particular window. Title is a traffic sign classification. Configure background is in CD. So you have to change the color into blue, like this one. So you have to fix the background color of this one. So label, so we have to change the color, that is our wish. So this is the font style of the particular tab. So font style say Arial, say 15 size, and the bold means the darkness of the text, and the sign image based on the label wise it is executed, and classify the image. Here the image has to be open and resizing the image and expand the dimension. Finally the array values will be decided. So based on the input image wise it is a which kind of class. So we cannot mention in the label, but we have to give that image based on the image features wise. The particular image like the model have to predict it is this kind of class. It is a 30 km per hour and it is a speed limit signal, like that way they have to identify. So the show the classify button, so we have to using the buttons. So upload button and classifying the image button and re-upload the image, so like that way. So everything, the color of the images and the background is a white or black, and this also font size of the particular buttons. So foreground is a white, I have to fix it into the multiple colors we have to use. So we have to using the red, try to using that. So the classifying the places relevant input and output. Finally we have to upload the image, open file or close file, width of the image and height of the image. If the image is not properly parsed, means they have to using the process has to be paused, is not executed anything. The upload button we have to fix it that, so upload an image or closing the button. So once every process will be done, we have to go with the main loop. If I run this, you can see that once I run this, you can see the output of this one. Okay, it is running, so just a minute. Okay, what is it happening? Okay, color name will be Yeah, so color is different. So we have to using the default color, so we cannot change that. Okay, so now I have to do again. So I forgot. So now we can see. So once I run this code, so here the traffic sign classification is the window. So the tkin does help to create this kind of on UI. Here know your traffic sign. So as a user we know about that. Once I upload here, the upload an image button is here. Once I click this, it is going to my local store system. Here you can see the local system is there. Here I have to choosing the images. Here the folder is there. Already we have a individual testing images, right? Okay. Yeah, test folder is there. Okay, wait a second. Okay, we cannot see. Yeah, so now it's here. It is a slippery way. Yeah, where is it? So in this image, the 10,238 image is the slippery road. So as a user, as a human, we see this already. So we know. Okay, where is yeah, here. So once I select this image, we know about this. So our model is properly predict or not. We have to come to some kind of understanding. Once I open this, you can see here the image was uploaded. Once I click this classify image, so the model will predict it is a slippery road. The text has to be there, right? Slippery road. Again I have to click it's a slippery road because of the same image is there. So we need this. We know this. Again I have to going to the upload an image. So I have to going to the speed limit 80. So this also we know. See this time we have to try it is properly predict or not. The image was uploaded. Again click this. It is a speed limit 80 km/h. Okay now. So same that format we have to using multiple traffic signs signals. Okay, so I don't know what is that exactly. I think it is a overtaking, not overtaking board. I can't clearly view this one. So we can try this. Once I upload the image, the classify the image is a no passing vehicle over 3.5 tons. Same like that. We cannot overtaking the image, particular vehicle. So again I have to go with a different image. What was that? Okay, it's a turn into the right. So right side you have to turn. So it is that turn right again. So you have to turn in the right side. So then, so it is a construction work. So the people have worked something like that. Board is there. Signal is there. You have to check this. Caution. The people are work like that. Yeah, road work. Something. So here we need to try it in another one. So you can see in this place. So what kind of image we have to upload? What is the class name and what is the label and what is the layer and value of the particular one. So you can see 1 cross 30,30. That is the range of the kernel size, the image kernel size. So everything is same kernel size. First one is slippery road. Second also slippery road. We have to two kind of time we have to pass, right? Third one is a speed limit 80 km/h. Fourth one is a no passing, no overtaking the 3.5 tons. Turn right back and a road work. Finally we have to give this, right? So now we can try to I will take the random image in Google. So traffic signal images. So everything is already we have, right? So I have to take in a different one. Okay, I think it's more or less everything same. I need one by one. No, it's not like signal. Science. Okay, so just a minute. Okay, we have to use this. So school traffic signs. I think it is available in our dataset, or I don't know. I cannot see that. So anyone see the labels? So I save this image. Yeah, save it into same. Okay, outer side. So downloads folder. I have to save this. I'm not give it into the same test folder. So I give it to the outside. So now I have to upload this. So the image has to be successfully uploaded. Now we're going to the downloads. Here the image is there. Okay. So now I click this and open this. The image has to be uploaded. So now I classify the image. Okay. It's not properly classified because of the image size has to be default. So we have to try with that another one. Because of already we have to fix it. Okay, so that's some resizing image problem. So that's it, not a big issue. So we have to try this. It's a go straight, don't take a U-turn like that. Yeah, so now wait a second. Yeah, okay, so that's it. So we can take the image, but we have to resize. That's it, not a big an issue. So I have using the same images. So finally we will see one okay, so which one? So what is that image is this? Okay, I cannot zoom it that. So the sign I cannot understand what is that. We have to see. So right away at intersection. So what is the triangle of this one? It's a yield one. That means the agriculture field is like that. So once I close this, automatically the window has been closed. So this is the way the traffic sign recognition is to be executed. Okay, so this is it is executed. So you can see the automatically the error is happened because of the image is not comes to our folder. It is not resized. Then only the error is happened. Otherwise, balanced image and the labels, everything will be properly predicted. Okay, so this is the way the traffic recognition we have to choose. Okay, in this one you have any doubt, so you can ask. So we will try to share the presentation and everything. So if in this one you have doubt, you can ask. Finally, we have see one final thing. Final option. Tomorrow sessions. First, anyone can set. So if you have any doubt or any queries, if you not any understand any concept, you can ask. I will repeat it again also. Otherwise, I will show one last and one final. I am not explaining about. I am not explaining about the codings, but I will show one interesting concept in OpenCV. Okay, sorry. Okay, so everyone asking about presentations and source code. No one can talk about the topic. Okay, so last but not least, so I will show one computer vision concept. This object detection. I don't know, so prevision they are showing or not. Now just I show in the output only. Okay, how it is predicted and everything. Yesterday's session link was stored into, available in description, so kindly check it out. Or else we will share it in the WhatsApp group, so don't worry about that. Janisa Tabitha. Okay, yeah. So I am not explain about this, just run this code, you can see. Oh, sorry, wait. Okay. Just I show the output only. Tomorrow I have to explain this one. RVS set why we need convolution. So in deep learning concept we have a different one, sir. Okay, so just a minute. So here you can see. Here the camera as a sensing device camera has to be detected. The model has been represent it is the laptop. Now you can see. So I think okay, it's not clearly viewed. So it is a mouse, and that is a cell phone. So it's a cell phone. So charge it. So it is a laptop. So most of the thing it is recognized into that particular one. I think it is a remote. So in my hand is in front of this that. So it is represented as a person hand, like person like that way. So behind the laptop, a remote and a person. So it is working into the object detection. Okay, tomorrow I will explain this one. And RVS set, so the convolution is needed for only image. If you using the text or any text, so individually the deep learning is having individual types. So CNN, RNN and ANN. So ANN is an artificial neural network. It is help to resolving the problem in text related. The RNN is help to the recurrent neural network, that is related to the audio and most of the audio related issues, problems. The CNN is mostly help into the image or video related issues. So deep learning is individually having the particular thing, because the data is having text or numbers, video or image or audio. So this is the most common way of communication, right? So then what we have to using the three different kind of type of deep learning concept is there. Instead of convolutional, we can't do. So if we use in the image means definitely we need a convolution only. So convolution major layer. We don't have another option. In case I have to go with that text wise means I can using ANN, artificial neural network I have to use. Once we are entering into the image concept, definitely we need a convolutional. We don't have an option, sir. Anything else? So finally, yeah sir, RBS said instead of convolutional still there is no option to using another one. So give a time, I have to check it. Once I reconfirm that, in tomorrow's session I have to reconfirm. In case anything is there, I will share you. Still it is working to analyze. It's an object detection. So based on the remote laptop. So it is a remote one, right? So it is properly predicted it's a remote. So tomorrow how it is work, what kind of model I have to using this one. This kind of thing I will show you in tomorrow. And also another one we have to discuss, that is a personal assistant. So already we know about the Python and the basics of machine learning concept, right? So we can do that. How it is this kind of basics, we have to create our personal assistant. How it has happened, we will see in tomorrow's session. Yeah, so we have to upload, but we cannot recognize. In case that is not present in our dataset means the images have been shown. Wait a second. That is represent to the error loading image. Or else any another option is there. Wait a second. There is two kind of things. One is that they have to giving there is none of the images there, or else they have to provide the output that is error loading image. There is two kind of options they have to provide. Only we have to pass it this kind of inside the kind of labels, otherwise we cannot get the output of this one. Percentage of accuracy. Yeah sir, so we can see, but here we cannot give a full training, so it is getting some errors. So I have to change the location of my dataset path. So then only the error has happened. Once I resolve it and I will share you. You can drive it and check it your accuracy. So we can see this. Once the training will be done, we have to see the count of accuracy, so how much accuracy is there. But we cannot during training in this place, and still now because of some kind of errors. So once I resolve it, I will sharing the code. You can try with yourself, or tomorrow onwards I have to show the accuracy. So okay, so still anything? No, limitation is not there, but based on the account of data set, they have to getting some kind of times. For around 50,000 means they have to take some kind of time. Approximately we have to set it's nearly 10 to 15 minutes for training purpose only. Based on the data's count increase, the time also increased. The time duration also increased. So once we have to using the huge amount of data, we have to changing the model. There is not a limitations to data sets. Shukanti or Nachalam, thank you ma'am, thank you. And AKM Alam Khan, thank you sir. Janisha Tabitha, ma'am, already we will reply to you. So already the third day attendance link has to be closed. So we will update on our WhatsApp group. So be aware. So already day 4 at today's class attendance we will pin in the comment. So can you check it everyone? Can you check it everyone? Okay, shall we implement this concept in blockchain? Jaya Prasanna. Yeah, it is possible, but give a time, sir. Once I check it and I will told you it is possible or not. So blockchain is one of the framework. It is possible, I think. So give a time. Once I check it and I will give a answer for you in tomorrow's session. Yeah, yes ma'am. No need to put your name in a comment, chat box. So you give it your attendance in attendance link. So already you will share it the link. Okay, thank you so much, sir. Thank you, everyone. Yeah, definitely. You will share the presentation and the codes, everything in our WhatsApp group, so you can check it that. Okay, thank you everyone. Thank you, faculties. So we will see you in tomorrow's session, and thank you for your listening and everything. Yeah, thank you everyone. So we will see you in the tomorrow session, and see you.